Hey everybody, it's Mr. V. Today we're going to go over one-point perspective, what it is, and a variety of different ways to achieve it in your work. Now remember that linear perspective is the illusion of depth on paper, on a flat two-dimensional surface. You're tricking the mind into believing it's seeing something in 3 dimensions, and you create an illusion on the paper to do that. And it's a very specific method. Today we're going to look at one-point perspective. Your essential questions for this lesson are, how do I create the one-point perspective illusion? Once you learn that, we're going to go into a little more detail. How do I overlap my forms? And then how do you make repeating forms? And I say repeating forms, like sidewalk tiles, windows, and so on. So as you learned in the last screencast, in one-point perspective, there are a couple of tools, imaginary tools, that don't actually exist within the piece itself, but they're simply guides or scaffolds there to help you. 2 of those are the horizon line and the vanishing point. The horizon line, once again, is your eye level within the piece, how tall you are in relationship to everything else. And the vanishing point helps you tell depth in the piece. You need both of these to continue. One-point perspective uses only one vanishing point, hence the name one-point perspective. All right, let's take a look at this image right here. This is an image in one-point perspective. Everything converges to one vanishing point. We have our horizon line and our vanishing point right about here in the center. And then every single angle on the z-axis, remember the z-axis is any slanted angles that connect to your vanishing point. It gives you that sense of depth. All right? And any slanted angle that's on here converges onto the vanishing point, like so. Even these edges of the buildings and so on, the tops of the cars, the signs and everything. All right, let's check out another one. You saw this one from the last screencast, the interior of this bus, and this has a horizon line and also a vanishing point. And this photographer had the vanishing point right in the center. And if we connect all the edges of the chairs, the fronts of the chairs, the backs of them, the top of the edges, they all converge onto a vanishing point. That is one-point perspective. All right, so it's got a horizon line, it's got one vanishing point, but one-point perspective also has a x-axis, a y-axis, and a z-axis. Now, this is the only form of perspective that you will encounter an x-axis, where any lines go straight left to right. It's the only one. When you get to 2-point, 3-point, you'll know you're doing 1 point correctly when you have an x-axis in it. And so the way you go about creating an image in one-point perspective is you simply draw the shape of the image facing you. If that were a square, it would be a square shape. You can see in these irregular shaped images, here is a rectangle. You would start with a rectangle and then simply connect the relevant corners to the z-axis. Well, here's how you know which corners to connect. If you can see them. If it's a see-through object, you'll connect all of the corners to your vanishing point. If it's not a see-through object, you will only connect the corners that would be visible. For example, this corner, the bottom left, and then the bottom right. We would not connect this top corner to the vanishing point because we would not see it with the rectangle. Draw your shape, connect the correct corners, and then close off the back of your form. Okay everybody, this is a demonstration of how to overlap your forms. Now I'm just creating a classical cube structure in perspective. These blue lines that you see in the computer represent where your ruler would go. Now to put a form that overlaps another, I'm going to stick this smaller rectangle behind it. The secret is to draw through your subject, meaning I drew the big large rectangle first, and then I drew a rectangle behind it, but I drew through the rectangle. That helps you know exactly where all of the necessary planes are going to be. And all you do is you simply erase what will be obscured by the shape in front of it. Here I am drawing a tall rectangle below it. Now that tall rectangle is slightly obscured by the one above it, but you can still see I draw through the subject to find out where the back of the rectangle will go. All right, now over here I'm going to draw kind of an irregular H-shaped odd structure, and I'm going to do 2 separate things with it. One, I'm going to draw this irregular form as if it were very long, and then 2, I'll draw it again as if it were very thin. And that's just to show you how you close off the back of your form. So first things first, I connect all of the relevant corners, not counting the ones that are obscured from our vision. You know that the corner is the correct one to connect if it is on the side of the form that you will be able to see. All right, so here I am selecting the back of our form. You can pick wherever that's going to be. Once you've defined that back portion of the form, you have all the information you need to construct the rest of the form. And now you're going to run into trouble. How do you connect the feet of this H? Well, it's actually very simple. Simply draw a horizontal line from the back of that first leg, and right there we've got enough information to create the foot of our H. Here I am connecting the necessary lines. Now, how do we know where to connect the top of that stem? Well, what you want to do is simply draw through your form. See where that line, that slanted line for the stem is, and then pull up a vertical line for where the back of the foot is. Where that intersects will be where you close off the line, and since it's a long form anyway, we're not going to see it. Okay, so here I am making the form a lot thinner. All I'm going to do is just erase some of the lines and redefine the back of my form to make it thin. Now we're going to run into some more problems here. One, we're going to have to draw the ceiling inside between the two legs here. All right, and then two, we need to redefine the back of the top of that stem in the upper right. Okay, so erasing some lines, and again to connect the back for both of the feet, just simply draw a horizontal line between the back of the left foot to the back of the right foot. Now to define like where we'll close off the back of that stem in the upper right, once again, draw through it. Connect the top of the stem to your vanishing point and then connect the back of your foot right there, and wherever those lines intersect, that's where you will cut off your stem. But as you can see, the intersection is obscured by the front of the form. What I'm going to show you next is what's called the repeater. Anytime in your environment when you have forms that are evenly spaced apart from each other, but they recede off into the distance along the z-axis, that's what we call a repeating form. You know, like a grove full of trees that are evenly spaced, or windows that are separated on a high-rise, or fence posts and so on. In order that our drawing is believable, we need to use a scaffold. And these trees are an example of what that would look like. You would use a scaffold to actually plan where your trees pop up out of the ground as they go off into the distance. And the scaffold is as follows. Create a block, create an X by connecting the corners, create a plus, and remember to connect the middle of your square to your VP to know where the middle of your plus goes. Use the points at 6 o'clock and 3 o'clock. Draw a line between the two and have it intersect the very top of your strip, and then pull the line down and continue the process again. Our next area that we would connect our slanted line to would be at 6 o'clock here and 3 o'clock here. Connect it, and so on. Connect, 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 connect. Every time you do this, you create one half of a plane. If you were to create sidewalk tiles, you would need to do this twice to have two sidewalk tiles. As you can see in this image, each block of the scaffold, as it gets further and further away, gets tighter and tighter and tighter together. Okay? So measuring doesn't work. And that is how I created these trees. Each tree stands up from the middle of one of those X's. And that's how I knew its placement on the ground. A non-example looks like this. Beginners typically try to make shortcuts by eyeballing it. They might get as far as the first cube, but then eyeball the distance as it goes. And how does that result? Well, the gaps between your forms become uneven, and also sometimes beginners don't bother to measure their ruler up, straight up and down, so we start to see slants on the outside of their forms. You can correct this by using a T-square or a triangle. So, as you can see, this scaffolding technique gives an example on how it lines up with all these windows. The same principle applies if I were to do a larger surface of windows. If I were to, say, focus on a tall rectangular portion of all these windows, you could do the exact same thing. That's how this technique applies. If you were not to use this, if you were to do this by hand or eyeball it, it would be a very strange, odd-looking structure. All right, so here's an example of what our repeating scaffold technique will end up resulting in. We're going to make several cubes that are repeating off in the distance. So you start with a square, and all I do is I define the back of that square first. Okay, very simple. That helps us know the plane that we're going to build the repeater grid on. All right, so you start with an X. That helps you find the center. Connect the center to your VP, and then at 3 o'clock and 6 o'clock do a slanted line. Now, in order to know where each square is going to be, you have to skip every other vertical line, all right? Because each vertical line represents half. So skipping every other vertical line, I then simply have my information for my cubes. I close off the front and the back of my cubes, erasing any leftover lines that I don't need, and then I will just add some shading to it, and voila! That is an accurate spread using the repeater. Now you do that for trees, sidewalk tiles, windows, and so on. But remember, every other vertical line. Hey there students, this is Mr. V. Today this is going to be a demo part 2 for drawing irregular shapes in perspective, and this is going to be the form that you see on the front of your Frayer document. Now I'm doing this in Photoshop, so a lot of the weird looking like moving dotted lines that you're going to be looking at, don't even worry about that, that's just me erasing. So as you can see, if you've watched the earlier demo and the other one on how to remove parts of basic forms, this is all just review for you guys. So the main concept with this is if you're going to make a big jumbled mess of irregular forms, you need to know which lines disappear and which lines stay. So for the purpose of this demo, just go ahead and watch how I create these forms and then how I make the decisions on which lines disappear. Now this is in 1-point perspective. All these techniques still apply in 2-point perspective as well. So you think in 3D. And erase your lines as you go so you don't get confused. And as you can see, we've got some forms that are jutting out in front of others. You might need to draw a form through it as if it were a ghost form and then remove parts of it to allow something in front to stick. So this piece right here, I wanted kind of the foot of the H form to cut in front. Then in that case, all you need to do is just redefine the front of the form that you want to do the cutting and then erase the junk that you don't need. And in 1-point perspective, you always start with the very front face of your new form, which is what I'm doing here. These aren't boxes anymore. These are kind of boxy, irregular shapes. And once you draw that front form, it's going to overlap a lot of stuff. And so it's just one of those things. Once you draw that plane, then you just make a decision on what needs to go and what needs to stay. And for example, this form, I decided that's going to be in front of that rectangle. So naturally, anything that was overlapped disappears. I feel that this video is pretty self-explanatory. The techniques don't change. I'm just going to kind of zip it and let you sit back and watch. It's only about 4 minutes long or so. So, basically watch this more than once. That's the way that you get these techniques and the way you get this understanding on how it works is to watch somebody else do it. And I hope this helps, and I look forward to seeing you in class. If you have any questions, let me know, and I'll be doing more of these in class in front of everybody too. So, all right, well, have a good one. Take care.